and this back part of the graph that I'm drawing, they said was made up of two little circle pieces, is that right? Okay, so this right here I'm picturing as a circle of radius 1 centered at that point, and this is a circle of radius 3 centered at the origin. They told you this was the point -4, -1, and then we had a line that did this, so this is the point 3, -3, and this is F. Alright, so is that all? Oh, G was given to you as 2x plus the interval from 0 to x of f of t dt. The first thing I probably would have done on this is to draw myself a great big line here at 0, since that's where this integral is starting. So if I'm calculating area, I'll need to use this as the center. Anything to the right is gaining area, anything to the left is losing area. So technically, positive area, negative area. Negative area, positive area. Okay, gaining and losing positives and negatives here. So that's the setup and the thought. A, find g of -3 and other stuff. Let's do that one first.
Okay, so you're going to need to get the area of the top semicircle.
I would go ahead and just do this first.
Yeah.
Yeah, we will. All right, 0 to -3 of f of t dt. That's the easy part. A lot of people forget that, the -6 thing there.
Yeah.
Okay, this is really just the area of the semicircle, and two ways you can do it. Come up with the equation and then actually take an antiderivative. You will get into trouble with the antiderivative because you have to use a u sub, and then there's nothing for your du to be.
I'm guessing you just take you just get
Find the area of a circle and cut it
half
4.
Yeah.
Alright, so area of a circle is pi r squared. Oh wait, this is technically going to be minus because we're losing this area, not gaining it. Okay, so even though that says we are adding this area, which will be negative. Area of a circle is pi r squared, so 9 pi, and then a fourth of that, so 9 pi over 4.
Bam.
I'll take that.
Easy.
Okay, good. Yeah, absolutely take that.
Question about number 2. I think I got an answer for what the.
We're not
I mean,
done with
Wait,
A.
part B
I mean,
or
yeah, part.
the second
second
part of
part
our
A.
A? Okay.
Is g prime of x just 2 plus f of t?
F of x, yeah, correct. Derivative of that is 2. Derivative of that just swaps out the x for the t, so 2 plus f of x. Then g prime of -3 would be 2 plus f of -3, which is 2 plus, all right, f of -3 is 0. So the answer is 2. Cool with that? Very good. All right. Part B, and please ask. I know we're going to rush through this kind of quickly, but if you need us to stop and talk about it some more, we'll do that. Part B. Get comfy. Okie dokie. Determine the x-coordinates of the point at which g has an absolute maximum value. Okay, how do we find absolute maxes? First derivative. So we want to look at g's derivative, and I might say g prime. It's not f prime, by the way. G prime is not f. It is that.
Yeah.
Okay. And we'll set that equal to 0. Okay, so basically what we want to know is where does f of x equal -2? Okay?
Exactly, yeah.
Where does f of x equal -2? Now, I'm looking at this graph. Here's -2. It's never going to hit it on the back end, but it does hit it somewhere over here. And that's a line. You should be able to kind of jump down the line or find a slope. I think it's 2.5 where it actually happens.
Yeah.
If you do the arithmetic, you get 2.5. So f of x equals -2 at x equals 2.5 or 5 halves.
What is it, just, it's a -2 slope?
Yeah, -2 slope, and I think it goes like the 0.11 and the 0.2 negative 1 and then the 0.3 negative 3, so you just split the difference in there. Okay, is that what I wanted? Oh, no, we're not there yet. Justify. Okay, we found the spot, but now we have to justify that it's a max. That's easy enough to do. This is a max because
Switches from negative
G
Positive.
prime, yada yada yada, positive to negative.
You're able to find it, you just have to say it.
Right. And I would word this a little bit better, but y'all have written this 100 times, so there you go. C, let's see here. Let's see. Find all values of x which the graph has a point of inflection. Okay, let's narrow down the possibilities. There are two possible places where this guy has points of inflection. That comes from second derivative. And if this is our first derivative, then the second derivative is actually going to be f prime because that one gets washed out, the 2 is gone. So I'll look at, some of y'all get really myopic on what exactly it means to be a point of inflection. It is where this equals 0, or where this is undefined, or at an endpoint. Now the endpoints don't really do me any good because I can't tell what happens on the outside, but there are two places where this is undefined.
In the middle and one of the 2 points.
At 0, that's one of them,
Negative 3.
and at negative 3. Even though it's smooth and connected, that's a vertical tangent line, so the derivative would have been undefined there. So our possibilities has possible points of inflection. Actually, that doesn't. There are possible points of inflection at x equals negative, that was wrong. At x equals negative 3 or 0. Now we just ask ourselves, where does g prime change signs? Or where does f prime, which is the slope, so where does f change direction? How about a negative 3?
Yeah.
No.
F was going up and then it kept going up.
Ooh, and back down at 0 it goes.
0 goes from up to down,
Yeah.
so we have points of inflection. At only x equals 0 because g double prime of x, or f of x, if you want to say that, changes sign there. And it doesn't have to be positive, negative, negative, positive, we just needed it to change sign, whatever it goes on. Alright, D,
Oh, I missed this one then.
really?
I don't know, it wasn't clicking that one.
Okay, find the average rate of change of f on the interval. Okay, there are two parts to this, the average rate of change and then the mean value theorem going bad. Average rate of change is easy, you're trying to make it calculus. Average rate of change is algebra 1 slope. Average value is calculus. So average rate of change just says take the 2 points and find the slope. And we're on the interval from negative 43, so they basically wanted me to use this point and this point to find a slope. And that was it. Okay?
Oh,
So
whoops.
it was f of 3 minus f of negative 4 over 3 minus negative 4. So
Which
that
is-
is negative 3 minus negative 1 over, what was that, 7? So negative 2/7.
Yes. Negative 2/7.
Well,
Okay. Second part, there is no point C in the middle for which f prime of C is equal to that number right there.
There.
Why?
Because,
Okay, it says explain why this statement does not contradict the mean value theorem.
because it has a cusp, it has 2 actually.
Cusp is a good word for us, for the like,
Yeah.
layman's terms.
Yeah, it's not differential.
There's a point where the derivative does not exist or it's not differential. Good. At x equals 0, f of t is, or f of x, excuse me, is not differential.
Yeah, where is it?
And that was the second of the two conditions that had to be true before we could use the v-value theorem. All right, so points, let's talk about it. You would have gotten for part A, woo, this was a freebie. 3 points on part A,
Yay.
1 for finding this,
Finding that.
okay. 1 point for finding the derivative,
And 1 point.
and then 1 point for that answer right there. So 3, quick and easy, thank you very much, points. Part B is also worth 3. Number 1, considering where g prime was equal to 0. Number 2, identifying your interior candidate point of 5/2. And then number 3, justifying why it's a max. Okay, saying that it was a max and then saying why. This is where they have not the most issue, this is where it's the most diverse, because some people use a math talk. Okay, we do a sentence, we're pretty good at that. It's a max because g prime changes positive negative, gorgeous. Some people will write, when x is less than 5 halves, g of x is positive, and when x is greater than 5 halves, then g of x is negative. It's the same thing that we just said. Okay, so however you choose to do it mathematically or Englishly, knock yourself out. Part C, wow, all that crap was only worth 1 point. You got all of it or you got none of it, that's it. So yeah, we went through a whole lot of work to just say it's got an
Is that,
important point.
is the thing up there, is D really 2 points?
Yes, it is.
Wow.
1 for finding this, and then 1 for explaining why the mean value theorem was.
I really think C should be 2 and that should be.
I know, right? That's the way I would have graded this one. But
You know,
they did ask you to do 2 things though. Oh, honestly, what I would have done is this. I would have taken 1 point away from this, like maybe not give you this point, and then put it down here somewhere.
That's,
Or taking 1 point away from this and putting it down there. All right. Baby bird problem,
No.
the landfill problem. Or baby bird in a landfill problem.
I think that's what describes it.
Okay. The beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the amount of, okay, so they haven't told us what W is, but whatever that is, it talks about an increasing model, that might be nice to know. Planners estimate that W will satisfy this differential equation, so dW dt is 1/25 W minus 300 for the next 20 years. Okay, that kind of makes sense. As W gets bigger, this number gets bigger, which means the landfill is filling up faster and faster. That's what's happening.
yeah.
W is measured in tons, and T is measured in years from the start of 2010. I'm gonna go ahead and write, I don't know if it's useful, but I'm gonna go ahead and write W of 0 is 1,400, because I got a feeling, this has a very initial condition kind of feel to it, so I
Yeah.
imagine that's gonna be important to it. That, this is some original function W, we don't know, but at time 0, we have 1,400 tons, which is 2010. Okay. A. Use the line tangent, gotcha, love that. Use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months. Gotcha.
Okay.
Alright, so, we need a tangent line. Well, that's pretty simple. Okay, there's our initial condition. We have W of 0 is equal to 1,400.
Now we need W,
And I need W prime or dW dt
so 1,400
at time equals 0?
So
Okay,
1,400 minus 300, so
good. That's something a lot of kids mess up on. They know time equals 0, so they plug 0 in here, but that's not 0. That is 1,400. So 1/25 times 1,400 minus 300, that is 1,100 over 25, which is 44.
Yeah.
Okay, so my line is y minus 1,400. Did I do that right?
Yeah.
Oh, okay, you know what, I would do this. W minus 1400 is equal to 44 times T minus 0. They really won't count all for variables, but they have defined what letters you should be using in this problem, so it might be nice to do that.
Yeah.
Or if you want to rewrite it, you could say W of T is equal to 44T plus 1400. That's not really important. Okay, box around that. There was more we had to do here. And use this to approximate the amount of solid waste in the container at the first 3 months, and then went ahead and told you that was T equals a fourth. Would they need to do that for y'all, or would you know that 3 months is 1/4?
Yeah.
You go with it? Okay, so if we do W of 1/4, that's nice, that's convenient, so we get 11, our answer is gonna be 1411.
Well, it did tell you that 3 months is.
I know, I'm asking, if they had not told you, would you have been able to deduce that the number you were using was 1/4?
I'd have to remember that T equals a year, that T equals.
Some people would have put
Yeah,
3
for the
there.
year.
Yeah, I like to realize that it was a year, and that'd be, oh yeah, so that's not a full year. But I have to read that, guessing, maybe, maybe not.
You know, just
I'm not
3/12,
exactly
and
sure.
then it's 1/4.
You know, it's funny, a lot of people just don't get, when you say something like, this amazes me, in algebra 2, or algebra 3 even, to algebra 2 really, I'll give them a problem like this, I'll say something like, oh, this. Okay, just humor me for funsies, all right? So they'll do this, they'll go 2, 4, this takes you back, doesn't it? Okay.
What?
What?
It happens way more than you think.
Put like a little R there for me.
Yeah, or that, or, you know, start tagging on some more zeros, or understand that it's not 1 out of 10, it's 1 out of 2. People just don't understand how to do remainders, and that not everything is out of 10. Time, I can't believe they get the time, they're like 15 minutes, so that's 0.15.
Oh.
No, 0.25, because it's 15 out of 60, not 15 out of 100, so. People think 100 is the only number you take stuff out of.
Well,
They're in
they're a
the
metric
metric
system.
system. I see.
I know, right? But our time's screwy, I don't
Yeah,
think
that's
our time
true.
would ever go to,
Time would never,
yeah.
you're right.
Would make sense though. B, find dw, second derivative. Gotcha.
All right.
This is where y'all messed it up, I think. All right, so, go. Here's your first derivative.
Mm-hmm. Couldn't you just,
Okay,
Multiply that.
You're good.
but that's what I did, just multiply it out
Fine.
and fix the derivative, so I got
What'd you get?
125 dw dt.
Perfect. Here's what most people mess up on. They think that this is your letter, your variable, so they call that just 1. But you're taking it with respect to time, not with respect to w, so it is dw dt. And if you go ahead and plug dw dt back in here, you get 1 over 625 w minus 300. That's if you clean it up. You stick that right there. Okay, so there's my second derivative. Use that to determine whether your answer in part A was an under or over estimate. Okay, when it says use that. Second derivative, we really only have one application for, actually 2. Acceleration, if it's a particle motion, which this is not, or concavity. So I say we test out the concavity. Here's the spot that we used, and here's the spot that we estimated. So what I need to do is look at what's happening between the point we know and the point we think we know.
Okay.
So think about any number you could plug in between, by the way, the W would be 1400 to 1411. So if I stick in numbers between 1400 and 1411, what does this become? What kind of number? What? Positive or negative?
Positive.
Positive, thank you. All right,
I was
so,
thinking of saying, I was
Yeah.
like, should I say?
so from times 0 to time 1/4, our second derivative is positive, which means it is concave
Oh,
up, okay? And I would write this out better. Okay, so if the function, they told us in the beginning it was increasing, so it's increasing and concave up, what's it look like? So is our tangent line
so the more,
going to be under or over?
so the more trash in there, the more we put in there.
No,
More,
we are putting more trash in we're putting trash in at a faster rate every year. We're putting trash in, period, but every year, the amount we put in, the rate that we put it in goes up every year.
but, yeah, I understand that, but what it's saying is that it's based off of how much is already in there. On how much is increasing is how much, it's based off, because it's based off of W, which is how much is already in there, so we're steadily increasing on how much we increase on how much is in there, it's how much we put, is increasing because we're putting more in there.
Right. But what it's saying is the distance between last year's trash and this year's trash,
Oh,
okay? If we go from year to year to year to year, you
Yeah.
see this number getting bigger and bigger and bigger, so it's increasing
okay,
more
yeah.
and more. Concave up, so ours is an underestimate. Okay. You would need to show in this one, the second derivative, you would need to say something about it being positive, which makes it concave up, then you need to draw a conclusion based on that. So ours is an underestimate. Part C. Find the particular solution. Oh, don't we all love these? Okay.
Yeah.
dw dt is equal to 1/25 w minus 300. Okay, what do they want me to do here? One more time in English.
Oh, she's saying the particular solution.
Okay. So what process, what are we gonna do to find that?
You have to get
Separate the variables, good. And I will say this, since we're gonna be getting W by itself anyway, I would push as much garbage to the other side as I could. This is about the best I can make it. Okay, I can't really separate the 300 from the W, but I can at least push the 25 over there.
That's just natural log anyway.
This one is, yeah, so do that. Now, this is a tiny u sub, but u is gonna be W minus 300, so du is dW, we don't really change anything. So natural log, absolute value, W minus 300 is equal to 1/25t plus c. I would go ahead and find plus c at this point. We know that W0 is 1400, so natural log, absolute value of 1400 minus 300 is equal to 1/25 times 0 plus c. Gone, so we get c is equal to the natural log of 1100.
Whatever that is.
Yeah, and leave it like that, because it's gonna wash out here in just a second. Okay, back to our original, where are we? Okay, so natural log of, can't do that. W minus 300 is equal to,
1/25 t plus natural log.
okay. Let's see here, that's gonna give us, E, exponentiate both sides, we're gonna get absolute value of W minus 300 is equal to, I'll do this in one step, 1100 e to the 1/25t. Everybody cool with what I just did, or y'all need to see it? You're good. Exponentiate, split it, simplify, blah, 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 blah. To drop the absolute value, we're going to need a plus or minus. And then we'll bring the 300 over. Now all we have to do is determine whether it is the positive value or the negative value. If I stick in 1400 for W, I'm sorry, 0 for T, I need 1400. If I stick in 0 for T, this is 1, and I don't get a 1400 unless I add, so my answer is 300 plus 1100 E to the 1 over 25 T. Cool. All right, point spread.
I'm guessing.
A is worth 2.
Yeah.
1 for finding the number 44 for getting your slope, and then 1 for your final answer. By the way, you don't actually get a point for the equation of the tangent line. That's sort of an intermediate step for you. 1 for getting the correct slope, and then 1 for the right answer. Part B is worth 2, 1 point for the correct second derivative, and then 1 point for your answer with reason, underestimate because. Part C is obviously worth 5. You should know this by now. Separated variables, 1. Both antiderivatives together are 1, plus C is 1. Using your initial condition, plus 1. You don't even have to get this right, as long as you plug the numbers in correctly to try and do the math, and then 1 point for the final answer. So if you're pressed for time, I really don't feel bad about stopping here and saying, okay, I got it, and then if I don't want to waste the arithmetic, just come back to it later. Right? But it's not hard, it's just time consuming.
Yeah. So it's like, you get your last point here, and then you're like, okay, I
And look at all the work I did to get that one last point.
So,
If you're a stickler like I am, you'd be angry. All right, number 6. So they have defined f of x thus. Piecewise function, 1 minus 2 sine x when x is less than or equal to 0, and e to the negative 4x when x is greater than 0. All right, part A, show that f is continuous at 0, and when they mention the word continuity, you better throw in a limit. You don't get credit for continuity unless you mention limit somewhere. What's the definition of continuity? What has to happen? 3 things have to happen.
the f of that has to exist.
Got it.
From the left and right have to exist, and they all have to equal each other.
Very good. So we need to find limit left, limit right, function value, and show that all 3 of those numbers are the same. Okay, so f of 0. Well, the part of the graph that uses 0 is this one, and when you stick in 0, you get 1. Limit as x approaches 0 from the left, which would be this part,
And also 1.
is also going to be 1, and the limit as x approaches 0 from the right is this one. And when you stick in 0, e to the 0 is 1. So the limit as x approaches 0 of f of x equals f of 0, so it is continuous. Okay. Part B.
Well, I did do A, right? That's one step.
For x not equal to 0, express f prime of x as a piecewise defined function. Yawn fest. Alright, first derivative. All they mean is to take the derivative of each half of this individually. Why can't we use 0, by the way? Why do they say, oh, it's everywhere except 0? Why
You
can't
can't
we?
make it E.
Because it,
Well, it technically belongs to this half of the graph.
but, wait, was it, because the derivative doesn't exist there.
Why not?
Because I'm guessing they know it's not an actual, like, because it's piecewise, I'm guessing.
What's probably gonna happen where they,
It's cusp.
it's probably a cusp, yeah, it's probably what's gonna happen. And they're just saying, don't include 0, because it may or may not be a cusp, we're just not gonna dig around in there. It's
Like, we don't
not,
want
by
to
the
waste
way.
your time.
Yeah, it's not, I mean, it is a cusp, it's not gonna work. Derivative here, that's gone, this is gonna be negative 2 cosine, is that right? Negative 2 cosine, yeah. Negative 2 cosine x for x less than 0, not equal to. Derivative of this, chain rule, negative 4 e to the negative 4x for x greater than 0. Then it says, find the value of x for which f prime equals negative 3. Okay, so here's what you should notice. if we're gonna get f prime to equal -3, this guy right here has an amplitude of 2. So he's not gonna be going past -2 and 2, so he'll never hit -3. E by itself would never hit -3, but when you throw that -4 front, it flips it, so it will. So this is the part I'm gonna focus on. I need to know when -4e to the -4x equals -3, and just do some really algebra 1, but algebra 2 stuff. Divide, you get e to the -4x equals 3/4. -4x equals the natural log of 3/4. So x equals negative natural log of 3/4 divided by 4. Okay. Last but not least, let's see, part C. This one gets people. A lot of arithmetic here. Find the average value of f on the interval from -1 to 1. Okay, we know how to do average value. That's our little 1 over b minus a thing. So 1 over 1 minus -1, antiderivative of -1 to 1 of f of x dx. Okay, the reason this gets a little icky is because this guy splits at 0, so we're gonna have to find, basically, we're gonna put that 1/2 on ice, and we're gonna find that area in 2 chunks, and then we're gonna divide it by 2. Alright, so, let's see here. It's gonna be the antiderivative from -1 to 0 of the sine part. And then plus 0 to 1 of the e part. Okay, here we go. Antiderivative of this one is going to be x plus 2 cosine x from -1 to 0. And, it's a teeny tiny u sub, we get a fourth minus 1/4 e to the -4x from 0 to 1. Okay. Let's start plugging stuff in. Alright, if I do, where am
I don't know, I didn't get this far.
Okay, plug in 0. That's gonna give you 0, cosine of 0 is 1, so 0 plus 2, minus, stick in -1, and we get -1 plus 2 cosine -1, whatever that is. I don't think I need that many, but I do, okay. Minus, let's stick a 1/4 here. Very good, that works. Alright, let's see, what else? Stick in 1